All right. I missed you guys. Not on a Friday. Maybe. I'm impressed with the turnout though. It wasn't looking good for a while. All right. Let's do a quick run through of what to expect, because one of the main things I want to highlight is that I call it practice 4 test 1. So it's longer than the test, obviously, but that's because there are lots of different things that I want you to be prepared for, and then I'll only test a subset of those things, right? And so I'll highlight this here. Copy. Right. The test will be on a subset of these concepts. But I wanted to give you kind of practice for all of them. Okay, so first let's talk about kind of the grade distribution. Now this is going to be approximate because what if there's a question that I think, oh, I need to add that one. But in general, let's walk through what we've covered in the course so far. We've talked about numeration systems, right? Moving between bases, right? And so numeration systems. I'll say roughly 10 marks versus, I don't know how many there are on that practice, but there's quite a bit more just to show you all the different options. So roughly, right, I haven't committed, I haven't pressed print quite yet, so I can still change my mind. But I like to do an approximation. What did we do? We did change of base stuff, and we did a little bit of binary arithmetic, right? So you'll see in the practice, there's a bunch of change of base questions, and then some binary arithmetic. Binary arithmetic, just for fun. Then we moved into set theory, and usually that's the section that people kind of have a fun time in, and you don't mind that there's a lot of marks there. So I am going to put about 20 marks there because there's a lot of kind of, I'm going to say, easy marks there. And so to be had. So set theory is going to be roughly 20 marks. There was a lot of different things that we did there, right? We talked about power sets, just kind of going off of cardinality, right? Power sets, subsets. Oops. Cardinality, Venn diagrams, kind of a money maker for set theory. Venn diagrams. What else is in there? Where did I put my? What else did we do in there? So I did break it up, the practice. Draw a Venn diagram, draw a Venn diagram, set builder notation, but that's kind of implied in sets. Another Venn diagram, and then we're on to combinatorics. So a lot can be done in the Venn diagram section, but maybe, just maybe, kind of set builder notation. This is chapter 1 of the textbook. Numeration systems isn't in the textbook, and so we just have my notes and the internet to go off of there, but I think that's probably plenty. 3 combinatorics. I'm gonna do roughly roughly 10. Roughly. It usually ends up being a little bit under 10 because there's a lot of questions that I don't like. I want them to be very, very straightforward when you read them so that you're not kind of second guessing yourself. A lot of these, right? In how many ways can a chairperson and a vice chairperson be selected from a committee of 25 senators? Right, that's pretty straightforward, something like that. Usually for combinatorics especially, I basically take these and I change some words, right? How many ways can a president and a vice president be selected from a committee of 30 people? That's the same question, right? Just different words, right? And so even though it doesn't feel like the same question, you know how to tackle those questions, right? So these are the things that I need you to be able to tackle, and that's all I'm expecting. Right? Easier said than done, I think. Combinatorics, we talked about combinations and permutations. We talked about multiplying possibilities. Probably the trickiest is the binomial theorem. Oops. Now, the binomial theorem, in case you didn't grab one already, I have some formula sheets for you to keep while you're studying. So if you didn't get a copy, put your hand up and I'll bring one to you. Hopefully you got one. I changed the first sheet or the first page because it used to be shorter. So I always reuse my formula sheets year after year. And then this year I said, you know what? No, I'm going to give them a little bit more. And I'm giving you the binomial theorem. That's really nice of me, I think. Means you have to use it. But before they had to use it and memorize it. So, and I'm also giving you the logic statements for the converse, the contrapositive, and the inverse. Okay. So you'll have, I'll bring fresh copies of the formula sheet, obviously not cobbled together like this. Bring freshies for the test, but at least now you know what will be on there. Okay. I think we can put, you know, 3 or even 4 of these 10 marks on the binomial theorem. And so that's kind of nice because these are all kind of word problems and that's not fun, right? And so I get that. Maybe you think they're fun. Well, too bad.
Would you be doing Pascal's triangle or could you just
you can just use the binomial theorem. Yeah. Yeah, if you're comfortable with the choose functions, then that's great. Yeah. Oh yeah, it does say, oh, that's okay. It's good for practice. But then you know you don't have to. Okay. Everyone's favorite. logic. I'll put it on a fresh page. Is it 4? Oh yeah, and this was chapter 2, of course. Logic. What do I have for that? Surprise. Surprise. 10. But everyone loves a good truth table, right? They're so fun. And there's like no words. So logic, things like the converse. So the converse, the inverse, and the contrapositive of a conditional statement. This is on your formula sheet now. So that's nice. And this is chapter 3 of the textbook.
And again, you're not giving us a formula. Your memorization.
For the truth table, you just do it. That's right. Oh yeah, and then negation. Try to keep those sentence ones kind of to a minimum. The negation is also on your formula sheet. Although maybe not explicitly. That's okay. Oh, they are in the equivalence laws. On formula sheet. And then truth tables. There were some things that went along with the truth tables, right? Logically equivalent, right? A tautology, right? All those things. And so there's kind of a little bit more there, but you can use truth tables to show that two things are equivalent, right? If they have the same truth values, then they're equivalent. Then Boolean algebra, which is from the video, but I'm only going to do 5 marks. I think that seems fair. Although if you're comfortable with truth tables, then the Boolean algebra isn't so bad. And because I'm curious if you want to start with the Boolean algebra problems or if you want to try them on your own. Boolean algebra. For Boolean algebra, all I really need you to do is be able to make a truth table for a Boolean function. be able to find the disjunctive normal form. The DNF of a Boolean function. Express the DNF as a sum of min terms. And that's it. This one's probably the trickiest. This makes for a total. Maybe I'll erase this because I'll talk more about it later. Total out of roughly 55. And you'll have the entire class, obviously.
What is the last line before the total, the last word say, is it?
Express this one, this one. Express the
very
DNF as a sum of min terms.
mid-
Min terms. How's about we do a run through of the Boolean algebra that I want you to have. There was more in the video, but just kind of linking to the truth tables. But before I do that, I do want to make a note here today that if a question is only worth 1 mark, you do not need to show any work. Okay. So there are some, I'm thinking in particular about the change of base questions where you could use your calculator, you're allowed to do that. Okay. And so there are going to be some that are worth 2 marks where you have to show how you did it because it's harder, right? And so I'll make a note here. Note, any questions? And you'll see the totals, the total marks look like this along the side, so you can kind of gauge how many marks it would be. Now, sometimes when I do the actual run through, I do adjust it a little bit, but not, not terribly. So any questions only worth 1 mark? Do not require any work shown. There's a few, but not that many. Let's see here. That doesn't mean there's no work to be done. It's just you don't have to show work if you know how to do it. Yeah, it's true. Only work worth 1 mark, do not require any work shown. All others require work shown. Obviously. Okay. So what I mean here, can use your calculator functions. Just to clarify. Use the calculator on everything?
Not.
That's fine too. That's allowed. Okay. Any questions? Okay. What I'm thinking is, how do I find, because I don't really want to use, can I use the notes for from the video, from the Boolean algebra one, and run through those again? So I don't want to use the ones that I gave you for practice, because then you don't have any extras for practice. Or I guess you could use the ones from the video for practice. I don't know. Since I have these here, and it might take me a while to find these. I'll jump straight to the Boolean algebra ones. 21. If you want.
And 19. No.
I updated I added some numeration systems. So on here, it should be
Oh, yes.
21, I think. Yeah, I bumped them with some numeration systems at the beginning. But yeah. Okay. Let's add a page here. Okay. How about some notes on Boolean algebra? Should have brought my actual notes. I'll have to wing it. Uh-oh. Maybe, just maybe. I didn't bring it. There's a section in particular that I would love to just steal, actually. Oops. Oh, wouldn't that be nice? Test 2 solutions. Well, I'd change it anyways. Here it is. Wait. Okay. So Boolean algebra, we can have Boolean addition and Boolean multiplication, which is different from binary, right? Because Boolean is just 0, 1, so you can't go to 1, 0 anymore. You have to go just flip back, okay? And so these are the equivalent of just switches in a, I don't know, a circuit. Okay? And so what we can say is, and there's kind of a lot of theory, blah, 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 blah. If we have some function, let's see here. This one's kind of messy. I want to copy it and steal it in. There. Okay. How do I get this without any writing on it? That was rhetorical. I think I know how. But how do I want to do this? Now you see it, now you don't. So so this is the formula sheet that you have in front of you. And we haven't done exponents and logs yet, or the quadratic formula. So they're just on there for later, obviously. Everything else we've kind of touched on. We don't really use this. The other section really goes hard on kind of this kind of logic this way. We just do it differently, but it's on there because it's on everyone else's, so whatever. But you can basically ignore that page. This is where you have your negation laws, right? So the negation of P or Q is the same thing as not P and not Q. Same thing with the negation of P and Q is not P or not Q. Remember, it just flips the sign if you distribute the not, right? So this one I would kind of make a mental note, right? That's kind of a useful one to have up your sleeve. All the other things are just kind of nice to have. There is, what was the other one that I wanted? Let's see. For the Boolean algebra laws, the only ones really that we're going to put a lot of stock in is that F plus, where is it? We're going to put a lot of stock in this one. So if we have x plus the negation of x, right? So not x, then that's going to be 1. Now the trick that we're going to use when we kind of unfold all these functions is we're going to multiply by 1, okay? Because the goal will be to have all the terms represented, okay? Because if you have x, y, z, each of those has to be represented in a binary situation, right? X is the first term, y is the second term, and z is the third term, okay? And so we're gonna use this one quite a bit, okay? But we can do things like use a truth table to show that the distributive laws for addition, let's say, is true. Oh, nice. So use a truth table to confirm the distributive law for addition. Looks like this. You can use the F plus GH, but I'm going to use the XYZ just because we have the XYZ on our practice. Okay. There's a difference between the two, and this is the function, and these are the variables, I think, or something like that. I can't remember exactly off the top of my head, but I'm going to use this one. Okay. So if I have f of x, y, z, then I have a function in terms of 3 variables, x, y, z. Okay. And so then I have 3 variables, which means that my truth table is going to have 8 rows. Okay. Therefore, 8 rows, right? 2 to the power of 3. Maybe I'll add that in. in the truth table. Can I call it a TT? Truth table. X, Y, Z. We do them in alphabetical order. Now remember, the truth table, we write them in order, right? 0, 1, 2, 3, 4, 5 in binary. And how do we do that? We start with 4 zeros, right? We take our 8, we split it in half, makes 4. And so we need 4 zeros. 1, 2, 3, 4. And I think on the test, because when I was kind of jotting stuff down, it was really hard without lines. So I think on the test, I'll give you the lines, which is also kind of an indication of what your truth table should look like, right? But at least you'll have lines to follow, and that might be nice. And I do kind of expect you to know anyways. 1, 2, 3, 4. Right? So we start and we split the 8 rows between zeros and ones, and then we take these 4 and we split them in half and alternate. So 0, 0, 1, 1, 0, 0, 1, 1. Then we alternate again, 0, 1, 0, 1, 0, 1, 0, 1. I'll make a note out here in binary. This is 0, 1, 2, 3, 4, 5, 6, 7. Right? If you converted those to base 10. I guess it's base 10, not binary. Nice try, Emily. And so we do them in order. Okay. Now, we want to show that x plus y times z. Now, the plus is going to be an or, and the multiplication is an and, right? Otherwise, we've seen all this before, and nothing's really new to us besides the addition is an or, and multiplication is an and. But knowing the logic rules, you don't really need those rules on the formula sheet where it tells you that, okay, if you multiply these things together, then you get well, it depends on what y and z are, I guess. They both have to be 1 to get a 1, otherwise it's all zeros, right? Okay. So x plus y times z. So I have x, I have the truth values for x already, all the possible values for x, and I want to make a column for y times z. Just in Boolean multiplication, I'm going to make y times z. Now 0 times 0 is 0. 0 times 1 is 0. Boolean multiplication is nice because it just is exactly what you think it's going to be, right? There's no curveballs. 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. You do x plus y times z. So now I'm looking at this column here and I'm adding it to y times z. And let's see here, just because I'm second guessing. Addition, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 1, and 1 plus 1 is 1. In Boolean algebra, right? In binary, addition, this would be 1, 0. That's the difference. Okay. Okay. So now I know how those behave. So now I can go to x plus y times z. Kind of keeping an eye on both my columns here. As soon as there's any sort of 1, it makes a 1. 0, 0, 0, 1, 1, 1, 1, 1. Might need more space. So now I have this side of the equation. Right? What I need is I now need to find x plus y as one column and x plus z as another column. And then I need to multiply those together. And if that's the same as this column that we found, then they're the same, right? They're equivalent. So here we go. I'll divide this a little bit more. X plus y is 0, 0, 1, 1, 1, score 1, 1, 1. I don't know why ones feel better, but they do. X plus z. So notice I'm not multiplying yet. This is a new column because I need to find these individually before I can multiply them. So x plus z. So now x plus z, I need to use my fingers on here. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1, 1, 1. And now x plus y times x plus z. So now I multiply these two columns. And the only way I can get a 1 is if they're both 1. So I get 0, 0, 0, 1, 1, 1, 1, 1. Now these since these truth values are the same, they are equivalent. Neat. Okay. So now we can work with some of these guys. If f is a Boolean function on n variables, so we have x1, x2, x all the way up to xn, we're going to stick to x, y, z. So we're only going to have 3, but you could have way more. Okay? Each term or its complement is called a literal. Okay? And a term where we have kind of a combination of all the possible terms is called a fundamental conjunction. So in our case, it's going to look like x, y, z. You can have so x can be on or off, y can be on or off, and z can be on or off, right? And so we have just 3 things that can always just be on or off. So here, x can be x or x bar etc. Right? So here, this is on and this is off. And so if you're representing each of the possible literals, then you know what they're all doing. Now, if you represent F as a sum of fundamental conjunctions, then that's what the disjunctive normal form is. So it's going to look something like this: x, y, z plus x, y, z bar, x bar, y, z, right? It's just kind of an expansion. Now, the trick we can use, there are two things that we can do to find the DNF, right? Which is the only kind of hard thing that I want you to be able to do. So to find the DNF of a function, I'll say of a Boolean function, we can either make a truth table. That's cool. Make a truth table any values, maybe I'll say any true values in the final statement are in the DNF. That's nice. You can build a truth table with just Boolean algebra, right? Addition and multiplication. There's no conditional statements or anything, right? And so it's relatively easy. The other option is to take all the terms and make sure that each of the literals are represented in each term. Make sure each literal is represented in each term by multiplying by 1. And I changed it. Did you see that? By multiplying by 1 in quotes. And simplifying. And simplifying. I'll grab an example. I want to have, oh, this one has 4. We could. How about this one? Copy. No, this one's bad. Because it has all the terms. Sorry, didn't catch that. That's about the min terms. Where's one that's better? Might have to use that one. I want to do this one first, and then I do want to do the last one on your, hey, on your practice. I'll give you a minute to try it too. Come on, paste. Man, that's annoying. it's not gonna do anything. It was like X, Y bar. Oh, there it is. Find the DNF of this function. So we have X, Y, and Z, which means that each of these terms have to include some version of X, some version of Y, and some version of Z. Okay. And so first thing that I would do is rearrange these in kind of alphabetical order, just so that you have some kind of method. Okay, and I am going to do the truth table, but I want to do the second one, which is kind of the weirder one first. Okay. And so what we're going to do is you're going to have f of x, y, z is x, y, and then I'll put a little spot for z. Plus x bar and a spot for y, and then z. Making room for each of the terms. Okay. Now I can't actually alter this function, but I can multiply by 1. It doesn't change. X times y times 1 doesn't do anything, right? So here we multiply by 1, and here we multiply by 1. It's just a special 1. In fact, if I need a z, right, this is the spot for z, and this is the spot for y. What I do is I'm going to go like this. I'm going to do x times y, or x times y times not z plus z. On your formula sheet, that's where we had it in Boolean algebra. The complement law, Boolean algebra law 8, just so you can refer to it. By Boolean algebra law 8. The negation plus the non-negated part makes 1. Right? And if you think about the truth table, you have a z, and then you have not z. And if you add those up, you're going to get 1s all the way, right? So you're just multiplying by 1.
And how did you get that first second row for x, y, bracket, not z plus z?
So here, my secret 1 is actually this.
Oh,
So this chunk here is 1. And that's the trick.
So would the other one be xz brackets, line over y plus y?
Perfect. I want them in alphabetical order. It doesn't actually matter, so yeah, that would work. But what I'm going to do is I'm going to do x bar, y bar plus y times z, which is also multiplying by 1, but filling in with a y that I need. Right?
If we're showing our work on the midterm, would you want us to write out that the Boolean algebra law 8, or could we just say the
No,
one?
you're okay to just use it. Yeah. Yeah.
so you would definitely need formula sheets to even know.
Well, this one you just kind of know. It's on your formula sheet. But if you know that this is the trick, and this is really the only trick that we're going to use, so it's not, it's not that crazy, but it is on your formula sheet just in case. So then what can we do? Then we use the distributive laws, but as long as we're careful, it's just like arithmetic. So what you're going to do is this x times y is going to multiply by the Z bar. And then a separate term is going to develop by X, Y times Z. So this is gonna split and make two terms. Okay? And so this is gonna make X, Y, Z bar plus X, Y, Z. Kind of showing. So then I can do the same thing, right? The X bar and the Z are just wrapping around the Y bar plus Y. But as long as you kind of make two different terms from there, then you're safe, right? And so keeping them in alphabetical order, X bar, Y bar, Z plus X bar, Y, Z. This one came from here and this one came from here. Right? They're just kind of attaching onto the inside terms. Okay. That's the DNF. Cool. What's the point? I don't know, getting algebraically flexy. So this is the DNF. I'll highlight this here. Do we have any duplicates? No. If we had duplicates, you would only list them once. Question.
Oh, so, the whole point of Boolean, if they're asking a question X, Y, Z, and X, Y plus X bar Z, you're imagining there's an invisible one on X, Y, Z, or one. It's always invisible one, not invisible zero. It's always one.
Always, so you want to multiply by one so that you're not changing the values, right?
Oh.
Because technically this is just shorthand, but when we don't list the Z, it means it doesn't care what Z is doing, but Z is still part of the circuit. And so that's why you want to have all the terms listed explicitly.
So it's just theoretically, if you say X plus Y plus X bar plus Y bar plus Y bar.
I should have written that down.
Oh, would that be X plus Y multiplied by invisible one?
You lost me.
Okay, never mind. I'm lost in myself too.
Okay, this is the DNF. So if the question asks, find the DNF, that's what you're going to do. Okay, what about the min terms? So the sum of the min terms, add page. So here, from the DNF, we can find the sum of the min terms. Well, good question. What is that? Let me copy this here. Copy. So f of x, y, z is this. Oh. And I'll just go like that. Okay. Hey, it looks like kind of slid off the page there. So now this term, let's see here. is really just 1, 1, 0, right? X is on, Y is on, Z is off. X is on, Y is on, Z is on. X is off, Y is off, Z is on. X is off, Y is on, Z is on. We can convert these to numbers, and you guys are way better at this than I am. 1, 1, 0. I have to cheat and think about the truth table. Is it 6? How about 1, 1, 1? I'm gonna go for 7.
Oh, yes, it says 7.
1
Oh, 3.
sold. So then the min terms is the sum. Now remember, the summation notation is just these being added together, right? So we're not really adding these values, but what they represent are being added together. Yeah. And so the sum of the min terms is, and I'll just do them in the order that they appear, 6, 7, 1, 3. And that's the sum of the min terms. This is the sum of the min terms. I need to write that properly, sorry. There. Usually you write them in order, 1, 3, 6, 7. Right? Or the sum of the min terms, 1, 3, 6, 7. Which is really just a compact way of writing this. Right? Just another way of communicating it. Okay.
Order doesn't matter.
Order doesn't matter, but in order might be nice. But it doesn't. What if I told you you could have done all this with a truth table? Yeah.
Do you want us to like multiply it out? Or just?
No, if the question, and I think I have a question that asks you to give the min terms,
On this.
yeah, of this function, and then express it as a sum of min terms in 21b. And so that's why I wanted to show you how to do that.
Will we just write it like that and say, okay, we're done, or do you want us to actually multiply it out?
No, here you're done.
Yeah.
Oh, so here, it's technically addition, but addition in the sense that it's or. So 6 or 7 or 1 or 3.
Oh,
So it's not really addition in the way that we know 6 plus 7 plus 1 plus 3, but those are just representing the binaries.
So, what if it was not, it's just X, Y not set, correct? And what if it just shows X, Y plus Y, Z? And that'll just give us.
Do you mean in the original?
On the question
Where is
that we have at 21. Not Y, Z plus Y, X. But we can only see 2 binaries each. It'll be 0, 1, 1, 1.
Oh, but you need to fill it out with all the missing terms, right? By multiplying by 1.
The
First.
one.
Yeah. Yeah, like we did here. Right, so here we only had this, but then you need to kind of fill it out so that you know what all of them, all the possibilities are doing. I suspect you might like the truth table version a little bit better. Maybe. Although this is fun, you have a choice. So, or we can use a truth table. Now let me grab the original copy. So we're gonna do the same function here. Wait, hey. Oh, come on. I don't want that. Okay, there. Okay. So you're told that it has to involve X, Y, and Z. We know what our truth table looks like, right? We have 3 literals, and so now we need 8 rows. That's a good place to start. X, Y, Z, 0, 0, 0, 0, 1, 1, 1, 1, 1. Hey, just in time here. 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1. Okay. So that's the first thing you need to do. And this is where I like to just jot down the base 10, even though I called it binary earlier. Because now I can just list them 0, 1, 2, 3, and I don't need to know them very well. 4, 5, 6, 7. Hey, that sounds kind of familiar, huh? We are about to do the exact same thing, just in a different way, so that's nice. Okay, so if you want to build out XY plus not XZ, we need to probably start with an X times Y column. I like to make a not X column before I do anything, just so I don't rely on negating it as I go, because that's really quite difficult for me. And so my first move is going to make a not X, because then I can make not X times Z immediately. Kind of a cheater. Maybe I shouldn't do that. Let's do them as they appear, I guess. But you are allowed to do that if you find easier ways. X times Y is 0, 0, 0, 0, 0, 0, 1, 1. I'm going to make a not X first, which is just the opposite. 1, 1, 1, 1, 0, 0, 0, 0. And then I can make a not X Z. So because I'm building out this here. So it's a different method of doing exactly what we did earlier, but it's separate. So you only have to do one or the other. Wait. So if you like this way better, which I suspect you might, then go for it. So we've got X times Y, we've got not X to build a not X Z. So now not X times Z, let's see. Luckily order doesn't matter. 0, 1, 0, 1, 0, 0, 0, 0. And now I can build the final XY plus not XZ by adding these two columns together. And I get 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 1, or sorry, 0, 0 plus 1 is 1, 0, 0, 1, 1.
Oh, you just did not X.
But
You just did not X.
I would have lost you if I started with this one and then did the other one. Make you appreciate this more. Because what did you find? That this, I zoomed out so it would be on one page. This summation can be summarized by all the true values. So all the ones that are ones, which means that in this case, X is off, Y is off, Z is on, right? And so here, this is not X, not Y, Z. In this case, X is off, Y is on, Z is on. Not X, Y, Z. In this case, X is on, Y is on, Z is off. And in this case, they're all on, X, Y, Z. So then the DNF is this plus this plus this. You also have the midterms. 1, 3, 6, 7. Pretty good.
But there will be separate question for truth table, using as truth table, and there will be another one for using midterm. Or what's this?
Well, it's practice for the test. So not necessarily. Yeah. I'll ask you to find the DNF, which choose your own adventure. Whether you use a truth table, you have to show me if you use a truth table, right? Or you have to show me algebraically what you've done. But either way, it doesn't matter to me, right? And then write it as the sum of the midterms, whatever way you want to do it. I don't care, but for 5 marks. How's that sound? And then so here, I guess I want to try to keep it on the same page here. The sum of the midterms of 1, 3, 6, 7 from out there. And then I can remove this page. How's that? For 5 marks. Pretty good. Okay. Any questions about that one? Or Boolean algebra in general, I guess? Or the test?
Could you show the addition example that you had?
Yeah.
They always said it's slightly different. And I'm just...
Yes, it is. And maybe I'll just nab it. It's at the top of this one here. Yeah, the addition 1 plus 1 makes 1. But that's the only difference. Maybe I'll bring this into my notes somewhere so you can have them. Probably should have done that. Yeah, it's all available. I'll just sneak it into our solutions here. Which I haven't posted because we're just making them now, but
Oh, for the addition, if there's a one, it's just a one.
yeah. So kind of more tame, I think, than binary addition and multiplication. Well, multiplication, I guess, is fine. Okay. I'll make a note here. There. Okay. I know you probably haven't had a time to run through these questions, and that's totally fine. But are there any that you want to go through together? Or do you want to save them? Savor them?
If you guys have any like questions instead to go through.
Yeah.
I don't know any specific question, but maybe could you just refresh over like when to know permutation and when to know combination? Yeah. So it can be kind of tricky with the word things. That's like one thing I always mess up.
And now I'm like, order matters in one of them? I can't remember which one. Does anyone remember?
What combination?
I feel like it is, but let me see here. I'm just gonna find it. Because I feel like I had it highlighted somewhere in our notes. Okay. Order is important in permutations, but order is not important in combinations. That's not, you know, super, super helpful, but let me just snag this. Because I remember thinking, well, how the heck am I supposed to know if order matters here? So, oh, I'll take a poll of the people who are here because you get a say. Do you like these questions? They're just kind of like math. You've got the formula for the permutations of n and k, and you've got the formula for n choose k on your formula sheet. But then we're using the factorial cancellation to show what it would be.
Okay, so the question would give us n and k.
Yeah, so it would be something like this. Calculate the permutations of 10 and 4 by writing out the formula and then canceling out as much as you can. Show your work, basically. So then you would use the formula where you have n and k. But then I'm just making sure that you know to cancel, that you can cancel the factorials. That can be something. Maybe not both, but one of them. That's reasonable.
I think both.
Both is great.
I think it's
I
good,
love
yeah.
both.
Much rather
Yeah.
the word problem.
What
This
does
is
that
very
knock
good
off?
for the class.
Oh yeah, that's 4 marks out of 10. That's
Oh,
really
yeah.
good. Well, and then we can sock it to them with the binomial theorem. Well, you win some, you lose some. Oh, here it says this is not on your formula sheet, but then I'm so nice this year that I added it. So that's not true anymore. On your formula sheet. But you don't need to use, don't need to use it. If you just write out the choose functions, that's fine, like this.
Four marks for that one.
Well, I've got 3 here. That's like half of our combinatorics marks. That's pretty good. Because, okay, I like these ones. What do you think? So it's the license plate ones or phone number or something like that. Right, so a typical social security number has this format. How many social security numbers are possible if the first 2 digits cannot be 0? Right, so then you write out your slots and you write out how many options you have, and then you can multiply through and you find something huge. That one's fine, I think. Something like that. It's usually license plates or, yeah. Okay, so we're at a solid 7 marks. We just need to fill another 3 marks. How is this 2 marks? I don't know. It's like a 1 mark. But because I want to see work, I guess.
Why the second one, 1 through 9? Not use the first two
Oh,
digits.
because the first 2 digits cannot be 0.
I just don't know.
So there will be some conditions on some of them. And then you just make adjustments. How many 5-member committees can be formed from a group of 15 people? Well, as long as you recognize the structure of the sentence structure, right? That's from 15, choose 5. 15, choose 5. Use your calculator, or you can do the math if you want. You don't really get extra points for doing the math, so just use your calculator. But you can check.
You said if it's 2 mark, you have to do work, and then 1 mark you can do calculation. Calculate.
Yeah, in this case, this is showing your work. I don't just want to see 28.
Oh, yeah.
It's like bare bones here, right? But I want to see where this 28 came from. Right? So it can be like very minimal. Oof. This one's tricky, right? I realize I'm working backwards, but it's because we started with those fun ones and moved our way up. A club consists of 9 men and 12 women. In how many ways can they choose a president, a vice president, a treasurer, and secretary, along with an advisory committee of 5 people who cannot also be in any of the 4 positions? In this case, so I will say I'm not going to do something like this because it's very hard, right? If you don't have time to kind of think about it. And so, but you would make a slot. First, you would choose your president, and then you would say, okay, then I'm going to choose my vice president, and then I'm going to choose my treasurer, and then I'm going to pick my secretary. But with each position filled, it decreases by 1, right? And because all of these have to happen at the same time, we're saying and in between, so you're multiplying. But it's this little guy, the 17 choose 5, right? Because there's 17 remaining out of the 21, and you have to choose 5 advisory members. And so this one is what makes it difficult, right? This part is essentially the same as the license plate or the social security number question, right? We're just adjusting the numbers as we go.
Why is it a combination for the 17-5? Because doesn't the order still matter if you're choosing 5 people?
So in those 5 people, though, it doesn't matter. You're either in or you're out.
So would a way to kind of say to choose permutation or combination, kind of like if it's either you're in and you're out, like on and off, then it's combination. But if there's sort of,
Yeah. So I suspect, let me see, where's my calculator? Oh yeah, it's right here. So here, because there's a difference between if you are the president or the vice president or the treasurer or the secretary, so then order matters, right? If you were picked for this spot, then that's different from being picked from this spot. And so you could rewrite this section as a permutation. So you could say, okay, this is the same as 21 permuted 4 ways, right? Or by 4, I guess. And then the choose function, because then you're just grabbing a bunch of 5 and they're either in the group or not.
And you're saying you're not gonna put that on this.
No, I don't like those. I guess I've said it now. If it's on there, I'll have to take it off. I promise. This one's nice though. In how many ways can a chairperson and a vice chairperson be selected from a committee of 25? Same thing, so now you've got these different positions, right? And so you can just list them. It doesn't really matter if you do the vice and then the chair, but first you have 25 to choose from and then you have 24. But this is the same as a permutation, right? But I like to do it just this way. So you don't really need permutations because I can always just handle it with making the slots, or at least the questions that we do, I can always just make the slots and talk my way into it or out of it.
That should be 4 marks.
Solid 4 marks.
It's too hard.
I'll make it worth 4 if you do both versions.
Oh, please. I'll take that.
Oh, I regret that immediately. But I think 2 marks is pretty good still. Right. So one of these? No? Sure. One of these? One of these because they're fun. Why not? And one of these. Yeah, where are we going to take some marks from? Set theory, maybe. Maybe we don't need a full 20 from set theory.
Definitely not.
Who knew you'd be waiting more for logic? Or, sorry, for combinatorics.
Well, there's Venn diagram. Yeah, there's Venn diagram.
But Venn diagrams are easy.
That's gonna be 8 marks. No,
I think it's probably like 10
Yeah.
at least for a Venn diagram. Well, maybe not 1, probably 2 different Venn diagrams.
Two. There's gonna be 2 questions for Venn diagram.
Why not? The one that I did add one. I did add one like this. Something like this, maybe. Should we do it together? Or maybe try it first. It's question 9 on your practice. This is a 3-set Venn diagram. I'll pause the recording so you can try it. And there's not a bunch of dead space. Just back up here. Even if you're not quite finished. Like I said, so we'll label these. I think the most natural labeling will be A, B, C. But you'll just need to rotate it visually if you didn't use that labeling. There. So like I said, the first thing you want to do is you want to start here with the 9. Right, and so they purchased a bunch of different fruits, total of 225 customers, and Some of them purchased apples, some of them purchased blueberries, cherries, but they're also allowed to buy apples and blueberries, apples and cherries, apples and blueberries and cherries, or all three. That's all allowed. So like I said, you want to make sure that you start in the center with the 9, because now you're going to have to subtract that 9 from all the other areas. Yeah. And so moving up, 64 purchased blueberries and cherries. Now, blueberries and cherries is this region here, right? In this case. But we already have 9 of those. Okay. And so I want 64 minus 9, which puts me at I have 55 in my notes here. I'll say start here. And then by the same logic, if 17 purchased apples and cherries has this overlap. 17, but 9 of those are already shown here, so 17 minus 9. I have 8. And same logic again. Apples and blueberries, 12, but I'm already showing 9. I get 3. So here, this is what I mean by draw the Venn diagram with the appropriate number of customers in each region, right? And so that means that you've subtracted the overlap, right? And then you can do the same thing for the rest of them. 114 purchased cherries, but that's just everyone in this entire cherry circle. But you've already listed 8 plus 9 plus 55 of those, right? And so here, then we get 114 minus 8 minus 9 minus 55, and I get 42 for just the cherries, right? Overall, yeah, it's 114 that bought cherries, but they could have also bought other things. And then same thing here, 152, or maybe not equals. So that's not true. 152 purchased blueberries, so here, but I've already listed 3 plus 9 plus 55 of those. Minus 3 minus, keep thinking 9 is 5, 9 and 55, maybe that's why, is 85. And then 25, bought apples, 25, but I've already listed 3 and 8 and 9 of those, so I get 5. There's another region. All the customers who didn't buy any of these fruits, there are probably other fruits. That's okay, jams, ciders, juice, whatever. 225 is the total area of the entire universal set. And so finally here, 225 minus all these guys, minus 5 minus 85 minus, oops, minus 42 minus 3 minus 8 minus 55 minus 9, and I got 18, which puts 18 out here. I'll highlight with the appropriate number of customers in each region, right? Because that's important. Nice. hard part's done, I think. Now, how many customers did not purchase any of the 3 types of fruit? 1 mark, 18, because you've already said it. How many customers purchased apples or berries? Or blueberries, oh gosh. Still B, I guess. But I was worried I had made a typo. Apples or blueberries. So they're allowed to be in the apple area or the blueberry area. I get 165 in my math, which is from 5 plus 3 plus 85 plus 8 plus 9 plus 55. Or if you prefer, you could add up the apples and the blueberries, the totals, and subtract the overlap. Doesn't really matter. I'm just looking for the number anyways. And then how many customers purchased only cherries? Again, it's just on your Venn diagram. So 42. Nice. Any questions?
Put you some number with my background.
I didn't put the U, but the U is technically out here, but I don't, you don't have to, because the rectangle represents the universal set, but you can if you want. Nice. Any other questions?
Stuff, one that's on here.
Yeah.
If we have a question like this, I guess we move on, but if we have one where it says constructed transmittal specifically, then
Yeah.
there'd be no reason to develop this. We literally have this one.
Exactly.
Yeah.
Yeah, so I'm not gonna force you to do the truth table, but I did want to do it on the practice. But if you've done the truth table already, then you can just use it. Yeah, totally. Nice. Any other questions?
Could you walk through that by your question?
Yeah. You bet. Okay. So what the question will say, so yeah, use the binomial theorem, so you'll know. And the binomial theorem is on your formula sheet like this, or some version of it. Let's see here. X plus y to the n is the sum from k equals 0 to n of n choose k x to the n minus k y to the k. Okay, yeah, exactly like that. Phew. So then what you want to do is you want to map this x plus y to your function. So if you have subtraction in here, then you need to make the y -3, right? Because if you have x minus 3, that's really x plus -3. So then wherever you see a y, you're going to put in -3. And then your n is 7 in this case. So then what you're going to do is you're going to map the summation from k equals 0 to 7. Okay? Just filling in the values that you have here. And then we have n is 7, so 7 choose k, but we have to run through k equals 0, then k equals 1, then k equals 2, all the way up through to 7. And then x is just x, mapping from here to here, right? But then n is 7 minus k, and then y is -3 to the power of k. But the k is going to change for each term. So then, if you want to ignore Pascal's triangle, that's totally fine. It's just a shortcut for the choose function, so you don't really need to use it. But what this ends up looking like is you cycle through these and you sum them along the way. So you go from k equals 0, so 7 to 0 times x to the 7 minus 0 is 7, and then -3 to the 0. So the first term looks like this. You can simplify that as 1 times x to the 7 times 1, just x to the 7. And then you move on to k equals 1. I'll be nice, I won't do 7 because 7's huge. 5's like reasonable, 6, 5, something like that. Right. 7 choose 1, x to the 6, right? N minus, or 7 minus 1, -3 to the 1. So it just kind of shifts it over. Then k equals 2, then k equals 3, then k equals 4, then k equals 5, 6, and then 7. And then you can simplify these, but I think I made it so that you don't have to simplify it. So as long as you just write it out, that's enough.
The second equal sign, why does it say 1 times 7?
Because 7 choose 0 is 1. There's only one way to choose 0 things out of 7.
Oh, that's what I thought it was just 7 minus 0.
Oh, no, so this is the choose function. So 7 choose 0 is 1. And where you could get that from is the outside of Pascal's triangle,
Yeah.
if you want. Yeah. So these coefficients, I do want to see the choose functions evaluated, but you don't have to simplify the rest because it becomes a lot of kind of collecting like terms and stuff like that. Or maybe I don't need to do that. If you're only writing this out, it would only be 2 marks. Would you prefer that? Then you just need to write this out and not do the choose function, although that's not very hard.
Is this question number 4?
It's worth 3 right now. I'd probably keep it the same. Yeah. I do want to see the choose function gone, just so you can show me that you know what the choose function is. And that it's not division, which people love to do. It's tempting, right? But it's not. So
Go over what the choose function is.
yes. So the choose function is from the combinatoric section on your formula sheet. It's that n choose k. It's at the very top. Let's see here. It's this one here, n choose k. So it'll be n factorial over k factorial times n minus k factorial. But I would encourage you to just use your calculator. So on your calculators, there's usually some sort of n choose k button, like an NCR. Oh yeah, nice. So if you want to do, for example, 7, choose 5, it's 21 ways that you could make 5 things out of 7. And so that's how the expansion works. But yeah, so this little guy here, this n choose k is just from here, but I would say just use your calculator. Yeah. And before calculators, they use Pascal's triangle, but we don't really need to. All right. I'll stop the recording, because otherwise it's just
Is
me
there any, like,
breathing.
note you would make on the logic section? Like any like thing you would think would be worth noting or just general logic?
Yeah. For the logic, no, I'm gonna try to keep it pretty simple for the logic and focus on the truth tables. So kind of Like you will, I'll give you a statement, so a conditional statement. And then because you have the converse, the inverse, and the contrapositive on your formula sheet, I will make you do that. And then maybe one negation, not three, but that's just for practice. And then the rest will be kind of like, make a truth table to show if it's true or false.
When you're doing the addition and multiplication of the truth table, is it similar to the Boolean algebra, or is there like a different sort of?
It's slightly different. Because 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. I guess it's the same as addition. So whenever you say or, it's addition. What about multiplications? P and Q, do we have that on here? Is,
Or the and, it'd have to be both is one, both is one to be one, right?
yeah,
So it's kind of just like coding.
so it is.
Yeah,
Yeah, they're the same. Yeah, yeah. It's the conditional that's tricky. There's no conditional on here. It's this guy.
I'm not sure if it's on.
Off the top of my head, I can't remember if it goes from a true statement to a false. That's the only time that it's false. The conditional.
Oh, okay, yeah.
That one, that kind of weird one. Yeah. But otherwise, yeah, I'm gonna go pretty hard on the truth tables just because, you know, you can either do it or not.
And on the actual test, we're gonna have formula sheets.
Yeah.
And
Yeah, I'll
we
bring
send
freshies.
some
Yeah,
of
they'll
those.
they'll be the same, except they won't have this old front page where I stripped through and made a bigger page, but it'll be the exact same.
And basically for memorizing stuff, like we gotta memorize like P and Q and these sort of things for truth tables, like how to write that out.
Yeah.
But like,
Yeah,
Is there-
and the conditional.
and what the conditions mean and
Yeah.
stuff, is there a lot of other stuff we need to memorize or?
No. No. If I don't have it on here, I don't really expect you to have it memorized.
Thanks so much.
You bet. See you on Monday.
Quickly go over those multiple locations and services.
Oh, yeah. Let me just, I'm gonna stop this here.